Hey, what's up guys? I'm here again and I'm going to do the second part of the problem for midterm 1. In our last video, we were left with this system. We have VS 5 volts going to a PNP transistor, which I labeled E, B, and C for the emitter, the base, and the collector. Off the base, we have 500 ohms RA, a resistor, and off the C, the collector, we have RM, which is 1 ohm, all coming back to the Arduino. So, just a little brief history. I want to give you guys the question. Using a large DC method, determine the region for the PNP transistor behaves when the microcontroller is outputting VA 5 volts. Do not use the MPN method and be careful when labeling E, B, and C. As you guys saw in the last video, we nailed E, B, and C. We got those down pat. So what I want to do is actually show you guys my midterm that was given to me. In my midterm, if you guys can see right now, our professor gave us a little, hint of how each of these are supposed to look. We have 3 regions we got to test. We got to test the active region, the saturation region, and the cutoff region. Once one of these is met, we're done. So what I like to do is I like to use the cutoff region. Once I'm done with the cutoff region, it's really easy to try to do the active or the saturation region. And I think the cutoff region is probably one of the easier ones to do, because you guys can clearly see the cutoff region acts as an open. As you can see, for the PNP, CB, BE, and VE are all disconnected. So what I've done right here is I've redrawn it compared to this. E, B, and C. So right now they're all open. I put 500 ohms coming off the B, just to verify, 500 ohms coming off the B. And I put 1 ohm coming off the C, 1 ohm coming off the C. And I also put a little checklist. It's always good to put a checklist just to get you guys in the mindset of what you're actually looking for. We need to verify that VBE is greater than -5 volts and VBC is greater than -5 volts. Once we've proven those 2 criteria are met, we're done. We're done. If we can't prove it, we're going to have to check the active or the saturation region. So right now, what I'm going to do for you guys is, I know just from this picture that VBE, even though these are still disconnected, VBE is going to equal 5 volts. And it's going to equal 5 volts because that, even though they're disconnected, current might not be flowing, but voltage is still going to flow between these 2. So we're still going to have voltage drop between E and B, which is 5 volts. VBC is what we need to test. So what I'm going to do right here is VBC. And what I'm going to do is I'm going to go back to the basics. I'm going to try Ohm's law. It's always good to go back to the fundamentals. Ohm's law. For those of you who don't know Ohm's law, I'm just going to put it up again. It's going to be voltage is equal to current times the resistance. So for VBC right now, I can tell you in cutoff, current's not going to flow. As you can obviously see, they're all disconnected. They're all open. So right now, that current is going to go away. It's going to go to 0. Once that current goes to 0, we can obviously say that voltage is going to equal 0. And now that we have VBC is equal to 0 volts and VBE is equal to a positive 5 volts, we can go out here and check. VBE is 5 volts, which is greater than -5 volts, check. And VBC is 0 volts, which is greater than -5 volts, check. So right now we have just proven in those 2 simple steps that this PNP transistor is in cutoff mode. So I'm going to put that up here, cut off mode. And we're done. Sometimes it's just as easy as that. Sometimes, you get lucky. Always check the cutoff mode, because right now, as you can see, how easy was that to check? It took us about maybe a minute. Check cutoff mode, it's easy points, and that's done. So I don't have to check saturation or active mode, because I know for a fact it's going to be in cutoff mode. And that's about it. If you guys had any other questions, you guys can post, and I can make another video for you guys. All right, thank you.